Hello guys, back again with another video. Today we're going to be graphing a sine or cosine wave. Some use cases of sine and cosine waves is that it's used to model light waves such as infrared, red, blue, anything you want. A sine wave can also visualize radio waves such as 2.4 GHz or 5 GHz. It's also used in piezoelectronics to make things like solid-state fans. There's a video on YouTube if you've ever seen that before. Also be used in calculating oscillations, such as how quartz crystals can be used to somewhat keep time in like a watch or a clock or an alarm clock or whatever. It can also be used in atomic clocks that are used for GPS, like on your phone, to be able to keep your location. Here's a little example here of what it would look like. It's typically used in the industry for computer graphics, signal processing, simulation, encryption and decryption, and even our AC electric grid uses sine waves. Isn't that electrifying? X. And then y equals a sine of bx, as long as b is greater than 0. What we're looking for is the amplitude and period. You'll notice that a sine wave starts at the origin and a cosine wave starts at the amplitude. Well, sort of the amplitude. It can also be a negative too. So it isn't exactly a negative for the amplitude. The amplitude always has an absolute value, which is why it's always positive. And the cosine can start on the negative. We'll see that in a little bit. The period is 2 pi divided by b. Fun fact, the period is also the frequency or hertz of the wavelength. A negative at the beginning reflects the wave across the x-axis. So this is what we were talking about a little bit earlier. You can see the cosine of theta over here as the lighter color, and then you'll see the negative cosine of theta as the red. And that'll show it that it flips across the x-axis. You'll also want to know a circle's quarters to calculate the wave of the sine or cosine wave to graph 5 points. These points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then you may be asking, why 5? Well, it is because 5 points show a full cycle. It's kind of like washing your clothes. If you've gotten that point in life, you wouldn't want a half dry cycle because you might end up with wet clothes. It's still incomplete. A common mistake is miscalculating the period by not flipping the b value before x. So if you have y equals a sine of bx, you might forget to flip a 1/2 to a 2 when doing the calculations. So for example, here we have 2. We have y equals -2 cosine of 2x. So first we're going to find the amplitude, which is the absolute value of a, which is this value right here, which is 2. And then our p value is interesting because it's going to be pi divided by 2. So it is going to be, or this should actually be pi, because the full cycle is 2 pi. This graph would normally, if it was like a 1 cosine of x, would look something like this, where it starts at 1 and then it goes here, kind of like that. However, for this one, we are going to multiply our amplitude by 2, or by a -2. Gotta keep that in mind. So it'll flip it the x-axis, so it'll be kind of like that. But then we'll take it one step further, and then we need to multiply it by this 2x. And what that is going to do is that is going to divide all of the pi, so pi over 2, your pi value, your 3 over 2 pi, and your 2 pi, or multiply it by 1 over 2. Ending fraction, or your ending sine wave, will look something like this. That's cool. So now we're going to try a little bit more difficult one, and this will show how the multiplication and fraction kind of plays into graphing it. So here we've got just a simple sine, so that means we're just going to have an amplitude of 1, and then we're going to have our p is going to be 2 over 3, or at least that's how I kind of think of it. It should actually be something else. But this is the value that I'm talking about here. Our p is actually going to be 2 pi over 3 over 2, which means that the 2's cancel. Pi over 3. So what we're going to do is we're going to multiply these values here. Our starting value, because of the sine, starts at the origin, so we got 0, 0. Remember, cosine starts at the sort of the amplitude. I can't remember the exact term for it. And then the sine value starts at 0, the origin. And then it goes to the amplitude. So we got our amplitudes over here. 0, 1, 0, negative 1, 0. And then we've got our x values over here. So we're going to multiply this real quick. We've got, and then we're going to come back down and intersect our second point. And then we're going to go to the amplitude on that third point, and then we're finally going to come back and intersect that fourth point. And that's going to be our graph for sine of 3 over 2x.